lot of things are there, right? Lot of things are there. We apply regression, we apply correlation with such data which are collected. For example, customer satisfaction. I have asked 5 statements on customer satisfaction, and I am investigating whether customer satisfaction leads to customer loyalty. Such kind of research is there, that if I am satisfied, then I may be loyal to the organization. For example, study on smartphones, iPhone. If I am satisfied with my iPhone, I will be loyal to the next purchase of iPhone. I will not settle for Android, right? So customer satisfaction leads to customer loyalty. Such kind of research, we deal it in interval data. Interval data, because in customer satisfaction, we are asking the question in the form of statement. And that statement is measured on 1 to 7 scale. So when one phenomena is asked twice or thrice with multi-dimensional item, one or the other, then we say that we are handling the aspect of construct. We are managing a construct, right? So this construct is customer satisfaction, and the items are related to each other. They are not independent to each other. They are related to each other. So all of you need to understand that what is the test which we can apply when we are handling research like this. Loyalty. We will ask some questions on loyalty. I request online audience, Sunita madam, to kindly turn off. The maximum. Right? So, if we are asking questions on a phenomena, that is customer loyalty, so you can see that customer loyalty is measured by 4 statements: 1 to 7, 1 to 7, 1 to 7, 1 to 7. So, in such kind of scenario, we will have to understand that what kind of tool, what kind of test I can apply. Okay, if I apply wrong test on these 2 variables, then I may be going for wrong direction. So first of all, you have to understand that which direction you are going to take. So we will be dealing with parametric and non-parametric test, but we need to understand what is the characteristics of the variable. If you have to understand what is the characteristic, what is the behavior of a construct like customer satisfaction, then it is interval data, interval scale data. It's a scale data. Scale data means when one phenomena is asked with multi-dimensional items. Multi-dimensional item. The items are measured on 1 to 7 scale. 1 to 7 scale, and these are related to each other. That means the relationship of customer satisfaction with its item is called as correlation. We generally deal with in research, everything is boiling down to 2 aspects. One is R, another one is R square. You will understand that correlation is the starting point. We collect variables for our research only and only if they are related to each other. I cannot do a research like the price of shoe in London is related to price of mobile phone in Delhi. I cannot do a research like this. I have to first of all go down to Google Scholar or Scopus or Web of Science. These are the 3 search engines from where you have to search the variables. Preferably, rank 1 is Web of Science. Web of Science. Number 2 is Scopus, and tertiary mode of research and finding out the research paper and journal is scholar.google.com. Right? So if I have to do a research, I will collect the variables and they must be related to each other. That means some correlation has to be there in the variables. So with correlated variables, that customer satisfaction and customer loyalty, they are somehow related to each other. Number two, the items with which we are going in the market, with the questionnaire, we go to the consumer, we go to the investor, we go to the employee, they are called as items, measurable items, right? Observed variables. Observed variables are the items, while customer satisfaction is unobserved variable. We call it as latent variable. Latent variable, and the item is called as observed variable. Relationship of construct with the item is called as factor loading. Factor loading, because many times when you will read a research paper, you will see these are the meanings, these are the words which are used primarily. So R is nothing but factor loading. How much association is there with the item, with its construct? How much it is related? Association is different, relationship is there. If I am using correlation, I am investigating degree of relationship. The word is relationship. What is the range of correlation? -1 to +1. So if factor loading is -0.60, so people are afraid of, sir, my factor loading is minus. Should I delete the item? This is the first question which even the bestest of the bestest researcher is asking. Sir, my factor loading is -80. What should I do? Should I delete it? No. Factor loading can be minus, factor loading can be positive, because correlation is in the range of -1 to +1. If factor loading is negative, that means your respondent is clearly saying that I don't like this thing. Higher the risk, lower is the purchase intention. He's saying this thing, that if the product is like made in China, that means it might stop after 7 days or 10 days, or it might work like 3 years also. So higher the risk, maybe the lower purchase intention. So the factor loading is the genesis of research any time. So if I say that customer satisfaction leads to customer loyalty, then I am talking about R square. R square is coefficient of determination. Coefficient of determination. And how much variance in customer loyalty is going to be determined due to customer satisfaction, that is called as regression. So number one, I am dealing with quantitative research. Number two, I was dealing with interval data, and with interval data, I will handle constructs like these, right? Customer satisfaction leads to customer loyalty. Both are interval data. And on interval data, first of all, I will investigate correlation, and then I will investigate a statistical tool like regression. For example, R square is 40%, 0.40. That means 40% of the variance in customer loyalty is due to customer satisfaction, right? That means 60% I don't know. 60% are other factors. That means I will again go to the Scopus and find out other factors, so that 40 can be 42, 43, 44, 45. So researchers are also in the misnomer that my R square should be 80%, 85%, 90%. Somebody cannot be God in research, right? That can also call for a spurious regression, bad regression. You can see that 25 to 60% R square, or max 70 to 75 is the maximum limits. So if somebody says in my thesis 33% is my R square, it's a good R square. For faculty like finance, 20% R square is also considered to be good R square. In regression, we have to understand that R square is only measuring the variance explained. Our main objective is whether this relationship is significant or not, whether customer satisfaction is significantly influencing customer loyalty or not. R square may be 20%, 25%. So we should not be R square centric researcher. You should be focusing on how much variables are related to each other and whether they significantly influence each other. If I say my friend has taught me yesterday and I passed my examination, That is a significant relationship. Although I passed with 33% marks, but I passed, right? That means my friend was important predictor of my success because I passed, right? But if I say that I passed with 80% marks, that means he was significant and highly significant predictor, and other variables were not important, like teacher was not important, library was not important, or any notes from the market, they were not important. My friend was the only one. So I have to understand that what I can do with my research. So I have to understand that I am applying correlation and regression. Now, correlation and regression, basically, they are parametric in nature. They are parametric in nature. Parametric. Now, is there anybody who can just contribute? What is parametric? Okay. Have you seen this kind of bell-shaped curve? What is this bell? Normal distribution. What is normal distribution? This online audience can write in the chat room. I'll definitely going to read. Okay. So what is this bell curve? Bell curve is telling us that our sample, when we say that I have gone to research and I have gone to the market and I have collected 385 respondents data, that means I am not collecting data haphazardly. For example, there might be 385 students here and I can collect data from this institute itself and my research is there. That means I have collected skewed data. Skewed data means lopsided results are going to be there. Then collecting data from Delhi. I should collect data from Delhi NCR, and I have to understand that my sample should be drawn from normal population, normal distribution of the population. That is a sample. What I am collecting data from the population has to be normal. That means I must know that what is happening in Delhi NCR. I must know the population characteristics. If I'm doing the search in Delhi NCR, I must know the data of the population, because out of population, we are going to collect the sample. We cannot say that I have collected sample haphazardly, randomly. Random sampling is the technique with which we collect the data so that it represents a normal distribution towards the mean of the sample. So population must be known to me. In parametric test, I must understand the population characteristics. If I say that random sampling is there, lottery method is there, so I must know how much is the total population. But if I don't know the characteristics of population, I don't know what kind of people are there. If I say that people are smoking here in Delhi NCR, but I don't know how many are actually the chain smoker and how many actually smoke, and how many have quit smoking and how many are non-smokers. I don't know. There is no published data. There is no statistical survey done, and there is no government agency who is talking about that how many smokers are there in Delhi NCR. When I don't know the characteristics of population, then how can I collect data which represents the normality of the sample? In such a scenario, when I don't know anything about the population characteristics, then what is the solution? Then I have to shift to non-parametric test. That means the cutoff point of decision by you will be there whether the traits and the characteristics of the population is known to me. When I write a thesis, I say that I am collecting data from state of Punjab. Some people say I am collecting, my thesis is for Tri-City, Panchkula, Chandigarh and Mohali. My study is from Delhi NCR, Gurgaon, Faridabad, Noida, Delhi, Sonipat. I am collecting data from Delhi NCR. I must know the population characteristics from where I am going to collect the sample. right? But if I don't know about the characteristics of the population, from where I have to draw the sample, that means I am shifting my base to a, you can say, not so perfect kind of test, which is a non-parametric test, which is taking care of not the mean. This is mean, you said, but in non-parametric test, we handle the results. We handle the results with non-parametric with the help of median. What is median? Median is mid value, right? You must have heard in 10+1 when we study the chapter of statistics. The first topic in measures of central tendency, we are studying mean. And the example is there that there are 10 students in the class and 11th one, his height is 6 feet, right? So he is disturbing the mean of the class. 10 students, average height is 5.7, 5.2, 5.4, but somebody is 6. So that is disturbing the mean value. So all of you should understand that am I talking about mean or am I going to conduct my research with median? If your population characteristics are known to you, then you will apply parametric test and you will be handling mean as the measure of central tendency to report the results. Mean will be the, you can say, central tendency value, which we are going to report. All the hypotheses are going to be revolving around mean. Mean, you know that this is mean, sum of observations divided by number of observations. But if I don't know about the population characteristics and my data is not, you can say, this is like the behavior of the respondent, like this, left hand skewed results are there. The sample is like behaving like left hand skewed, or my sample is behaving like right hand skewed. This is skewness. Skewed data is coming from my population. I don't know because I have randomly gone to Gurgaon and Faridabad and I've collected data who are going to be the smoking smokers in this area, and that data might be skewed towards right hand side. The data might be skewed towards left hand side. You might come up with the sample which may say that we don't smoke. Some people will say we are chain smokers. You might handle such kind of data. In such a scenario, then you are going to calculate and report the results with the help of median. Median, right? You have to shift your base. I mean, if a platform is not working well, if I am not meeting the assumptions, then I have to shift my base from parametric to non-parametric, right? So the researcher is the one who has to show that my results were normally distributed or not normally distributed. Statistically, you have to prove, right? I have to open a door and then in the door there is a room. But the door has to be opened by us, and that door is whether my data was normal or not normal, whether it was meeting the assumptions or it was not meeting the assumptions. If it meets the assumption, I will go with mean as the parameter, as the measure of central tendency to report hypothesis. For example, males and females. If I have to compare that the students are there, let's say 30 students are right hand side, 30 students are sitting left hand side. So the marks obtained by boys and the marks obtained by girls, right? In examination, marks obtained by boys and marks obtained by girls. So I will take a mean of boys, mean of girls. I will compare there is significant or not significant difference between the marks of boys and girls. That means I'm using mean. That means I'm using parametric test. So when you are dealing with mean, that means you are dealing with parametric test. And you are also stating indirectly that I have collected a data which is normally distributed towards the mean. So research, so the reviewer or any faculty can ask you, have you proved whether your data was normally distributed? That is the first requirement. You are saying there is significant difference between the mean of boys and girls. For example, if you want to compare your institute results with the institute of another eminence in Delhi, let us say another institute. So the mean marks of this institute and mean marks of another institutes, you are comparing and then you are reporting that our institute is best and better than the other institute. You're talking about parametric test because you are talking about mean. Mean score of this institute is better than the mean score of others. So parametric has to be applied if you meet the assumptions. Okay. The another thing is this one, I guess. Now we can slightly move towards this parametric and non-parametric. But let me just cover few more things to you. There is another type of data which we also handle. One, I said that it is interval or ratio. You know what is ratio data? You know what is ratio data? Ratio data is what is your age? If I ask this question like what is your age? Please mute online audience. Yes, Akanksha. Akanksha, please mute your mic. So what is your age? If I ask a question like what is your age, I am collecting data with ratio data. Because somebody will say my age is 46, somebody will say 42, 33, 26. This data is ratio data. And I can apply correlation and regression with ease. Because interval data or ratio data, I can apply correlation. I can apply any test with ratio data. Generally, the best data is ratio data. Highest order of data which should be collected is to be ratio data. That is why faculty in finance, they are dealing research with that CSR activity leads to organizational performance. ESG funds, environmental, social and governance funds. If I'm investing into ESG funds, my portfolio is going to be good portfolio. They are dealing with ratio data, right? Inflation. The faculty, those who research in banking and insurance, banking especially, what is the effect of inflation on Indian economy? They're dealing with ratio data, they're dealing with correlation, they're dealing with regression. And then they're explaining that the parametric tests are applied. And they're talking about mean, right? So all of you should understand that what you can do and what you should not do. You can do any tool or test with ratio data, but provided the normality has to be proved by you. Normality of the data which you have collected from the population. If you don't know about the population, then you prove that the results are applicable for non-parametric test. But if you have proved that the data was normally collected from the population, then you go for parametric test, right? So correlation and regression, we are going to end up by the evening today that what you can do with correlation and regression. So what is your age is a ratio data. But if I ask question like this, what is your age? 0 to 20, 21 to 40, 41 to 60, and above 60, right? Please tick a box. This is not a ratio data. This data is called as interval data. No, it has got 4 categories. 1, 2, 3, 4, and we say please tick any one category. That means this data is categorical in nature. It is not ratio data. It is not interval data. Interval means one phenomena is asked multiple times, right? So I am talking about categorical data. I am talking about categorical data, and this categorical data can have 2 aspects. First aspect, can I rank these 4 categories? Can I rank these 4 categories? Yes, audience. Can I rank these 4 categories? 0 to 20, 21 to 40. Can I rank? Yes or no? Can I order? Can I order these 4 categories. Order. Can I say these are younger ones, these are the older ones? And here we can have adolescents, and then we can have child also. The definition according to Factories Act is 15 years child, then adolescent, then the you can say younger ones, then middle aged, then older ones, right? So we can somewhere down the line we can order them. So that means this categorical data is going to be categorized as ordinal data. Now on ordinal data, am I going to apply parametric test or non-parametric test? This we are going to learn today. If the data is ordinal and ordered, the data is categorical. It is not ratio and it is not interval. It is categorical data and it is ordered data. What can I do with such variable? Which kind of test, which kind of parametric test I can apply? Which kind of non-parametric test I can apply? So by the end of first lecture, we are going to work and execute on ordered data with parametric test, ordered data with non-parametric test. Okay, so I have brought some data set with you and I have shared with you. I'll tell you which file you have to handle, and then first question of mine to you will be, tell me whether it is nominal, ordinal, interval or ratio. Then we will handle it is ordinal, then we will go for parametric or non-parametric. Another question is marital status. Marital status, unmarried, married, and third category is broken. It covers all categories. Separated, divorce, everything is covered under. Now there are 3 categories. Can we order? Can we say unmarried are happier than married people? No, right? So that is a skewed result, which we are going to say that unmarried are always happier than the married one. So it's a skewed result. It might happen that married people are happier than unmarried people. Imagine if the data is 40 to 50 years of people, 40 to 60 is the audience, and they are all unmarried. So you might happen to have a result that married people in 41 to 60 are happier than unmarried people, those who are into 41 to 60, because they feel lonely, they don't have kids. So such kind of things will come. But if you see 21 to 40, unmarried people will be more happier than the married people. Frustration level is less. Responsibilities are less. You can earn and you can relax with entire salary. Fine. So when we cannot order on a suitable base or a basic level of judgment also, and the data is categorical, then we say that I am going to handle nominal data. I'm going to handle nominal data. So what if I have collected nominal data? What kind of tool and test, what kind of parametric tool and test I can apply, I must know. Okay. Sometimes good papers by the doctors especially, they are written with nominal and ordinal data. They don't go for such kind of big shot variables like SEM. They only go with, a few of my students were from PGI Chandigarh, like nurses and the doctors. Every day they are treating 200 patients coming from Punjab, Haryana and other things. So they are collecting some data that the patient is male or female. What is the age of the patient? From which state they are coming? Himachal, Punjab, Haryana. From where they are coming? What kind of disease? So they were recording all the demographic profile, and then they are treating them that what is the root cause of the disease into such kind of patients. So in 5 days, they collect 1000 of data set. And with 1000 data set, they are applying parametric and non-parametric test to publish their papers and give some suitable judgment of PGI Chandigarh. Right? In PGI Rohtak, the audience might hail from Delhi NCR. So every doctor or every, you can say, psychologist can handle a data related to stress with respect to nominal and ordinal data also. Are they going to deal with mean or are they going to report with median? That we have to see today. Okay. So nominal, ordinal, interval, ratio. These are the four things which we are going to first of all understand, and then we have to shift our base. And software is a software, it will give you result into 2 or 3 seconds. So software is only a tool with which we need results, but what kind of result will come, that is the art of learning from the workshops like this. So when we say that I am going to apply a test, so test will be applied on a particular behavior of the data, nominal, ordinal, interval, or ratio. So these are the two session outcomes which we will obtain before lunch. And background is, now read the first line. If you can understand, in parametric statistics, information about the distribution of population is known. This is the baseline of the research. Population is known and it is fixed on fixed set of parameters. That means there must be some agency, there must be some publication, there must be some set of, you can say, environment from where I am collecting the data. If you are doing research in corporate governance, there is a body called as Province database, Bloomberg database. They have collected the data of Indian companies listed in the Bombay Stock Exchange and National Stock Exchange. The population, behavior, and characteristics are known. I know these are textile company. I know these are pharma companies, and I can collect data, 2 companies from textile, 5 from pharma. So I can collect, right? But if I don't know how many people are consuming alcohol based upon surrogate advertisement. Now, the recent news you must have heard is that Zomato, Swiggy, they are going to deliver alcohol at the doorsteps. Now, there is no need to go to a place and buy alcohol. Indian e-commerce agencies, they are ready to deliver alcohol in the doorsteps, right? So our recent research paper, which is going into an ABDC A category paper in US, from Indian side, we are telling them that there is a surrogate advertisement also. Surrogate advertisement. You know that Bagpiper Club soda, there is no soda actually, which is sold in the market. Fine. You see that there are advertisement of glasses, Kingfisher glasses, but nobody is selling Kingfisher glasses. But surrogate advertisement is there for Bagpiper Club soda. They are actually selling the Bagpiper. So how attitude towards surrogate advertisement is influencing attitude towards alcohol, and that too into e-commerce platforms. This is the novelty. This is the area. So I don't know how many people have the attitude towards surrogate advertisement. Who will tell me? Is there any survey? Is there any agency who has published? RBI, SEBI, any PricewaterhouseCoopers report, any Ernst and Young report? There is no certified agency who is telling me that these much people in India has attitude towards surrogate advertisement and this much audience is actually consuming alcohol. There is no data. So there is no way you can go for this kind of distribution of population which is normal. Straight away, you can understand that there is no population parameters known to me. So you cannot shift your base to parametric test. You have to go for non-parametric test, right? In non-parametric, the information about the distribution of population is unknown. So such kind of research, attitude towards surrogate advertisement, they are unknown. I don't know. My thesis was social media and investor behavior in 2015. And my supervisor said that social media, you might not get the data of social media users, right? You don't know how many people are using social media to get information of a stock and then investing into National Stock Exchange. There is no agency. You might get a data from Government of India that how many users are there in WhatsApp in India. 46 crore. Sometimes number is coming. That means somebody has measured that 46 crore are subscriber for WhatsApp in India. There is a number. That means the population is known. But how many people are actually transacting through WhatsApp? I don't know. For example, on a Facebook, there is an advertisement that Tata Motors has changed their CEO or they have fired Cyrus Mistry. For such kind of information, I am building my mind that let me now exit from Tata Motors because they have fired their right chairman. I guess Cyrus Mistry was chairman. So they fired. So how many people are processing such information? That means I am bound to handle non-parametric statistics. I don't know how many people are reading Facebook pages and then investing into Indian markets. So when I don't know the distribution of the population, I should shift my base to median and non-parametric tests. If I know the population, I must go for mean and then I must report through parametric test. Okay. This much line is clear. Fundamental line is there. Because when we also study, we have to ask a point of split off. And this is the point of split off. Am I going to shift to room A, parametric test, or I am going to sit into room number B, non-parametric test? Which measure of central tendency I am going to apply? Because hypothesis, when we will frame hypothesis for median in non-parametric, mean for parametric, right? So parametrics are based upon assumptions that the distribution of population from the sample is taken. This is normally distributed. This is the right. And then we say that parametric tests like t-test, one-way ANOVA, such kind of tests are applied. Otherwise, if t-test is not applicable, then I have to shift to a non-parametric test, which is called as Mann-Whitney U-test. So first of all, I must know what is t-test. I must know what is the definition of t-test. Only then I can say that I am working with substitute goods, substitute test. So what is t-test? T-test is significant difference of the mean of male and female. Marks of mean of male and female. India versus USA. Brazil versus Russia. In BRICS nation, I'm saying that mean of Brazil and mean of Russia. Is there any significant difference between the exports of Brazil and Russia? So I'm talking about parametric. But if I'm talking about median, so I will be using U-test. U-test. If T is not applicable, significant difference of the mean of two countries, male or female are two. So if I'm saying that there is a significant difference of male and female, that means there are only two categories. When we are comparing mean of two categories, we are applying t-test. But if t-test is not applicable, then you can simply say, because t was not applicable, therefore I have applied this Mann-Whitney U-test. U-test. Right? For example, east, west, north, south. And I'm selling something. I want to check whether my sale of air conditioner is coming from east, west, north, or south. That means there are more than two categories. There are four categories. If I'm checking mean of sale of four directions, I'm talking about one-way ANOVA. Right? If two are there, T is there. If more than two is there, ANOVA is there. So ANOVA is also parametric. Like here, common parametric statistics are t-test and one-way ANOVA. If there are four categories or more than two categories, we shift to ANOVA. But if ANOVA is not applicable, then I have to go for non-parametric. Non-parametric is this H test. H. Right? So we will be solving today T. We will be solving today execute, run ANOVA. We will run U test. We will run H test. Okay. If two are there, T test, more than two, ANOVA. But if these are not applicable, if parametric is not applicable, I must know how to apply U, how to apply H, and submit the results. Okay. Look at the figure. Can you see the figure? Parametric, non-parametric. So basically, you can say that parametric test is more robust test because they fulfill some assumptions. But non-parametric can be skewed data. It can be a skewed data. It can be left side skewed data or right side skewed data. And the kurtosis level, if you see the bell, there are three shapes of bell: mesokurtotic, leptokurtotic, plutokurtotic. So kurtosis can be any, right? It can go haywire. It can go beyond the ranges of ±3 also. Kurtosis can deviate. Skewness can deviate. So non-parametric don't meet such requirements that there should be bell curve. There should be normally distributed. So I've shared this PPT so that you should read time and again that who are sensitive, who are normal, who is fit for large sample size. When we collect small sample, 150, 180, 40, such kind of sample, when we collect small sample, you must understand it is bound to be not normal. Small data sets, small sample studies are generally not normal in nature. They are bound to behave like left skewed, right skewed, kurtotic values are haywire. So for small sample size, generally non-parametric tests are applicable. But for large sample size, like 500 respondents, 680 respondents, 900 respondents, when the sample size is large, generally it happens that the tendency is that the data set bounds to become normal, right? So large sample size, that is why in any good university, if you find a professor, senior most professor or an experienced professor, he will always push his or her scholar for collecting large data sets. At least 385. They will say 400, 900, and the researcher is always running away from that professor that I must go for lesser sample size. While the professor is giving you the right direction, supervisor means he is giving you the direction that collect larger data sets, because with larger data sets, this bell will be achieved and you are going to work with parametric tests, which are more robust and effective tests. While the lower sample size like 150, 180 or 200, you can apply non-parametric. They are not incorrect tests. Let me tell you, they are not inferior test also, but they are substitute to parametric. Both are correct. Yes, sir. If I have to choose between the two, parametric is more valid. But non-parametric is not incorrect. It is only an alternative to the parametric. When I cannot work with mean, I can report with median also. Normal. Then we test. Then we test them. That is for time series data, time series. But for here, you see the difference between the two, right? Into a by cleaning, that is unit root test, we make the data stationary first. We take out the sensitivity of the data. For example, gold prices. Now gold prices are 78,000, 7880. It is touching 24 carat is 78. But if you see 2004, it was 4,000 also 4,800. If I'm doing research like this, the sensitivity is very high. Into stationary data, also break it. Yes, as for parametric. For time series data and panel, we do stationarities to remove the seasonality effect and time effect. So they are the basic requirement of time series is that this is cross-sectional data. Normality of cross-sectional data and stationarity of time series data are different things. We are making the data stationary. We are making, I'm giving the answer. I'm making the data stationary by taking log of the data, which is having highly sensitivity, to convert it into a normal distribution. So that to get the parametric. स्टेशनरी करते हैं उसमें से रूट निकाल देते हैं because it tends to behave like the stationary despite the spikes in the data. So it can be panel data. Panel data is also applied in stationarity test. With leveling chow test, there is a time and but many researches they do like BRICS nation, they or SAARC countries, right? Just give me 5 minutes, then. Yes. हाँ. हाँ. So not yes. Population, known population, so that we can collect appropriate sample from the known population. If I know that this is the sample of this is the area of Delhi NCR and the population is known, I will go and collect sample appropriately from that particular normal population, and that sample will represent the normality of the population. Sample should represent, because from that sample I am going to generalize my result for the other researchers. So to conclude this thing, the value of central tendency, you can say that I'm talking about normality in the probability distribution. Gaussian ideal curve which we talk about has to be normal, and in non-parametric it can be arbitrary. Okay, so after this break we are going to shift to this one sample, two sample, one way ANOVA, two way ANOVA. These kind of parametric tests we are going to apply. What kind of data? So we will see the behavior of the data and then we can apply the results. But if left hand side of the test are not applicable, we have to move to Wilcoxon, Mann-Whitney, Kruskal-Wallis. Mann-Whitney is U, Kruskal-Wallis is H. Right? So these are related pairs which we are going to see. Okay. This PPT is available. So we are going to meet after 12:40. 11:40 we are going to meet.